The institute has a strong focus on research and development.
The Faraday cage what you are looking right now is of 100 kV AC and 140 kV DC generation setup, where we are performing high voltage testing and measurement experiments for MTech level students. Our basic research for this setup is partial discharge analysis. One of the recent technique in this field is ultra high frequency. We are also doing some experiments for liquid dielectrics. So we have 80 kV breakdown test setup for oil breakdown. We are also doing research in the field of frequency response analysis of the transformers, and the windings what you are looking are being used for measuring the frequency response analysis.
IIT Bombay has recently consolidated its nanotechnology research activities through the formation of a Center for Research in Nanotechnology and Science, that is CRNTS. The formation of this center has been made possible through generous grants from the Department of Science and Technology, Government of India. At IIT Bombay, over 60 faculty members from 10 different departments are working together in the broad areas of nanotechnology with support from various government agencies and private industries. This research has resulted in over 1,000 high-quality publications in the last 5 years in international journals and conference proceedings and a large number of patents. Some of the research activities at IIT Bombay in the nanotechnology area are on par with some of the best institutions in the world. Significant progress has already been made after the establishment of the CRNTS, and the facilities created at the CRNTS are made available to all the researchers in the country.
The Department of Chemical Engineering, with 30 core and 3 adjunct faculty members and about 150 research scholars, is the favorite research destination in the country, attracting about 30 scholars every year. The research in the department is multidisciplinary, leading to collaborations within as well as outside India. The research areas include major frontier areas like pollution control, water, renewable energy, as well as emerging areas like nanotechnology, biosystems, along with the classical areas like transport phenomena, reaction engineering, etc. The research scholars are also involved in an event called Research Scholars Symposium that showcases the research to the industry and hence promote industry-academia collaboration. Apart from papers and patents, the scholars have also won many laurels like Young Researcher Awards, Manudhane Awards, Shah Solomon Awards, etc.
The automation lab is equipped with benchmark experimental setups which are interfaced with PCs and computational software. These setups are used to validate algorithms developed during the course of our research work. The lab has excellent relations with research and development industries such as Honeywell and General Electric, and has also developed very good relations with Government of India research labs like BARC and the Department of Science and Technology.
The main focus of our lab is on understanding the mechanism of cell division both in bacteria as well as in mammalian cells. We mainly work with two proteins, namely tubulin, which is found in eukaryotes, and FTSE, which is found in prokaryotes. While tubulin is already an established drug target for anti-cancer compounds, FTSE is rapidly emerging as an antibacterial drug target.
Research is actually a synonym for life.
It is like watching a caterpillar grow into a butterfly, a culmination of all the possibilities.
The uniqueness of IITB research is you can get all research facilities under a single roof.
The natural gases have remained trapped in various geological horizons for thousands of years until interrupted. This provides with an idea to combat climate change by injecting the anthropogenic greenhouse gases like carbon dioxide into the deep-seated rock horizons. We have devised a triaxial experimental setup wherein the underground in-situ pressure, temperature conditions are replicated and then the rock is subjected to a gaseous environment. This will help to understand the mechanism of migration, storage, absorption and the transportation of the injected carbon dioxide into these reservoirs and the subsequent changes in the physical mechanical properties of these rocks.
The ambience which I found here was really great, and later on when I came in contact with faculty members, they were very cordial and very helping nature.
My topic of research is mixed refrigerant Joule-Thomson cryocooler. The objective of the research work is to carry out investigations on heat exchanger for mixed refrigerant Joule-Thomson cryocooler.
Broad areas of research in Department of Aerospace include aerodynamics, propulsion, structures, and controls and dynamics. Key focus areas include experimental study of turbulence, computational fluid dynamics, experimental and computational hypersonics, microcombustion, and several other cutting-edge technologies. With best-in-class and inspiring faculty, research at Aerospace is simply a pleasure.
you can take a student out of IIT, but you can never take IIT out of a student. That zest, that inquisitiveness, that curiosity, it remains forever.
Our institute has gloriously evolved from being teaching based to being driven by the fuel of research.
IIT Bombay is helping me to evolve by providing expert guidance and state-of-art facilities and infrastructure. We are working on aerosol synthesis and pulmonary delivery of nanoparticle lipid matrices. So far, we have demonstrated control over particle properties which can make these lipid particles as advanced drug delivery systems.
Being a researcher at IIT Bombay is a very enriching experience. I get a lot of excellent support and guidance from the faculty.
The excellent library and bibliographical facilities available here go a long way in pursuing our work.
Apart from excellent research facilities, the environment here provides a quality life and encourages every individual to grow as a person.